Are
Yes,
you guys
yes.
able to see?
Yep,
Okay,
we can see the
awesome.
screen.
Thank you. All right, so I just wanted to show the consolidated minutes from the last time I combined the 14th and the 21st before we went out on break. So I hope everyone got these or received them in their email. So we talked about Sosutha coming on, and we talked about the Smart Switch test plan under review with fine tuning. We talked about all the contributions from Jimmy, so thank you, Jimmy. And we also have a meeting about member Camille Kudnik had an issue where he was seeing 5 objects created when he feels there should be one. And we've talked about it over and over, and so there was a suggestion we have a dedicated meeting. And then we also have behavioral model that week, and so I'm just trying to gather my thoughts around behavioral model. But we had a summary of the issues completed, to do, and draft, and in progress, and the change week over week, and then follow-up tasks here. So if you always, as always, if you want to read the full, everything that happened in the meeting, scroll way, way, way down here, and you can read everything we talked about. And if you guys have changes or things you'd like me to change on this meeting note, I've asked before and you guys seem to prefer it this way, but if you want any changes, just let me know. So, any questions about those before we move on? So I'm just gonna say that's a no. And this week we have, so I've updated the project plan. I hope you guys can see it here. And I have a couple of updates, but we also had Riff wanting to discuss 2 of his. So Riff, did you want to go ahead or take over the presentation?
Oh yeah, so I think we have Junhua here.
Mhm.
Check. Yep,
Yeah.
Junhua is here. Yep. So Junhua, would you like to go through the data plan app design? Yeah, and
Yeah.
I can go through the gateway bypass
Mhm.
afterward.
Okay.
Yep. Okay, sounds good. Yep, Junhua. Yeah, the stage is
Did
yours
you want
now.
to share, Jimmy, or Junwan, did you want to share, or do you want me to find it and share?
Okay, I can share my screen.
Yeah,
Okay.
please feel free. Yeah. We'll let you know when we can see.
Oh. Now can you see
Yep.
my screen?
Yeah, we've got it, Junwan.
Okay.
Mm-hmm.
Yeah. Okay. If any question, feel free to pass me
Sure.
at any time. Okay. Yeah, in this PR, yeah, I introduced GameWay 2 data plane app high level design.
Mm-hmm.
Okay, and for easy to view it, I used to the view mode. Yeah.
Mm-hmm.
Okay, let's brief go through this document. Yeah. Okay, the first one is the background section.
Mm-hmm.
Yeah, the data plane app is just another packet process engine running on CPUs. It adds extra capabilities onto Dash keyboard ASIC.
And it sits in the user space there?
Sorry, Kristen, can you repeat it?
It looks like it sits in the user space above the kernel space there in your drawing.
Oh yeah, it's just a block diagram.
Mm-hmm.
Yeah, it's
Okay.
a Eurospace program. Yeah.
Yep.
but I think if you want to implement in kernel, I think it's also okay. Yeah, but for this design, we do it in your space. Yeah, in your space as a data plane app application. The data plane app serves the slow or exception path of packet processing. It's a supplement to the underlying P4 pipeline or other vendors ASIC. Because some function it might not be easy to do in ASIC or in our P4 pipeline, BMV2 P4 pipeline. So we use this data plane app because it's running on CPU and we can write programs. We can use various programming language to write the feature. It is much more easier. Yeah. Also in this data plane app, it can optionally implement some set APIs which are not proper easy to be done based on the ASIC SDK. And okay, this document only focus on describing the design of a data plane app example. So it's not for production. It's just as a proof of concept, how it cooperates with the Dash pipeline, especially for BMV2. Yeah, as a whole to implement a data plane engine, Dash data plane engine. Yeah. Also, this application will use VPP framework because the VPP, the open source VPP project has provided a very extensive packet processing framework. Yeah. Yeah. The next one is section is the project scenario. Yeah, I think this data plane app can help 3 scenarios. Maybe it can do more, but yeah, here I list the 3 scenarios. The one is the main scenario is stateful packet process. Yeah, comparing the pipeline, it's just use basic. It's just use search and map and action approach. Yeah, we add a flow table. That means we collect the following logics in this flow table. It includes necessary metadata and actions. Because in pipeline, yeah, we just look up the table to and store the basic forwarding parameters, and then we do proper actions. So we summarize this information in the flow entry and save it in a flow table. So for this stateful packet process, we basically have flow creation, flow deletion, and flow edge out.
And this is bridging the gap. What's the gap that we're trying to fix here with this?
Do you mean this one?
In any of the 3. Maybe Riff, could you explain it a little more?
Yeah. So I think we actually have a few gaps right now.
Mhm.
So for example, today in the BME2, we don't even have a way to do the flow timeout at all. Because
Mhm.
BME2 is, and we are currently using the single switch architecture, so it doesn't really have the flow like idle timeout
Oh,
capability.
idle time. Uh-huh.
Yeah. And another thing is that even though we switch to PNA, for example, we switch to PNA support idle timeout, but it's like on the entry level. So for stateful connections, what we usually do is then we create a pair of flows. So we end up with having two flow entry that needs to pair with each other. So let's say we have the forwarding flow, we have the reverse flow, right? And let's
Mhm.
say one of the flow, not really one of the flow, but when the flow gets timeout, it's not really one side of the flow gets timeout. It's actually timeout both. Say,
Mhm.
for example, if the forwarding flow doesn't have traffic, but reverse flow all the way has traffic, we should not timeout.
Mm.
If the flow really gets timeout, we should not only delete one side of flow, but we should delete a pair of flow. So
Mhm.
those things will not be available if we just simply do it in the in the P4. And
Mhm.
those things will need the help from the the data plan application. So so this is like this is why we're saying like this is bridging the gap. So to help like we move forward, and even after we switch to PNA, this will also be like very helpful. So that's basically like the background.
Yeah, thank you. Thanks. It's
Yep.
been a couple of weeks, so needed to get back on track there. Okay, keep going, Junhua. Thank you.
Yep. Thank you.
Okay. Okay. Next scenario is about HA. In HA, we have inline flow replication and flow bulk sync operation. And for inline flow replication, the active data plane app will create flow and sync the list flow entry to the standby. Generally, it will set a sync request message to the standby data plane app. Also, this sync message will have the original packet with the dash metadata header glued. Yeah. After standby data plane app, recreate the same flow and it will act the active data plane app to finish the whole flow creation process. For bulk sync, that means we need to replicate a batch flows, that means multiple flows from one DPU to another. So this operation need a data plane app to finish it. During the bulk sync, the active data plane app will work the flow table based on the sync method. Maybe it's we can use a perfect or range sync method. Then after work the flow table, it will generate batch flows and set them to standby data plane app.
Is that pretty fast, Junhua and Riff? Or we can choose what kind of sync we want with the bulk sync and tune it, or
Yeah. It really depends on the implementation. So this is like tunable.
okay.
Yeah.
Okay. Next scenario is flow resimulation. Yeah, for flow resimulation, Riff has presented another high-level design document. Basically, if some policy is changed, we need to apply the latest policy changes to the some flows. Then the SD controller or lossbound controller can notify data plane to do the flow resimulation, and data plane app will get this notification and reach the resimulation operation. Later, we will have a sequence chart to maybe it will explain the process in detail. Yeah. Okay. Next, yeah, for the
Hey, Riff,
okay.
I have a question about this HA initial flow replication. So the flow replication will be replicated to all, for example, the switches connected in this architecture, or this will be only replicating to one specific switch? So basically, does the design allow to replicating, for example, just between the pair, or does the design allow to replicate to, for example, three in a design?
Yeah. So that's actually a very good question. Although it's a little bit out of scope, but yeah. So I think when we designed the HA, so we actually thought about it because essentially like what we're what we are currently doing or everyone's doing right now is just like a pair. So we think between the pairs. However, if you really think it through, it's just a chain replication. So if we would like to add more nodes and it's chain replication, I think technically it's doable, but it's also a lot of work. So it's I think using the pair is what we have right now, but conceptually we don't really we can extend. So that's why like in the HA design you see the in the whole design we're trying to avoid using HA pair. We are always using HA set because then for future extension. So hope that answers the question.
Yeah, and Riff, the specific packet, right, when it arrives on the one that basically gets inline flow replication to the other one, in case this is inline, because I understand the bull flow sync will happen in the background, right? But the inline one, right? Does the packet leaves the original DPU as it's being replicated inline, or basically it leaves the secondary DPU? So basically it arrives on the first DPU, gets assigned, creates the flow, gets assigned metadata, and inline replicates with the flow to a secondary DPU, and only once the secondary DPU establishes flow, only then basically it leaves from the secondary DPU or leaves from the primary DPU. Basically, like from where the packet basically later leaves to the wire.
So I'm not sure I fully captured the question, but the inline flow sync. So basically, the packet lands on the first DPU, let's say in the active DPU. The active DPU will say, oh, the flow is not synced, but the flow is actually created. So you will attach all the metadata to the packet, and then send to the other side. And the other side replicates the flow, sends the sync ACK back, and then that basically activates the flow, and the flow is ready to use. So that's how in high level how inline sync work, but I think practically there are still like more room for optimizations. So that's actually depends on vendor. So here in the behavior model, what we are doing is we just simply attach a header to it.
I see.
Yeah.
Hey, Riff, on the HA flow replication section here, is the assumption that the flow is replicated inline in the forwarding plane, that in the forwarding path, so that you replicate the flow before you forward the packet? Is it blocking, or is this something where the packet is processed in the forwarding pipeline, and then in parallel to that, you do the replication of the state?
I see. Yeah. So this is also a good question. So basically, it's a So inline sync right now it needs to be happening in a blocking way. So basically, then the sequence is we go to the active replicates to the standby, and standby act the replication moving back to the active activates the flow. In that case, the packet will leave the active, send to the real destination. So why it's designed like this is actually because, as I say, there is some weird thing that happens. Okay, so the packet lands on the active and then you send it out. The replication happens like asynchronously. Okay, so the packet already leaves a pair, it sends out, but the replication is not done yet. So in this case, let's say the replication actually failed. So there could be multiple things that could be happening. So first thing is that now we do a switchover, the failover can happen, right? So if we detect the network failure, because in this case, very likely will be, and then the standby side is not really having the flow. At that time, if the next packet comes, we say, oh, the packet doesn't have the flow. So it's not a SYNC packet. Should we create a packet? Should we create a connection or not? Let's say we create a connection, and then there are still multiple things could happen. So if the forwarding side, then maybe okay. If the reverse side, it may not even pass echo. So because echo is also asynchronous. So there's a lot of like fun stuff going on. That's why like the replication is currently in a blocking way. So you make sure that if the flow is created, it always gets replicated. There is another thing is, and if the second packet, let's say we create a flow, we can correctly, we can still create a flow by passing the echo. We may make a different decision. Let's say there is an ECMP group, or let's say there is a NAT, which actually does the thing, and those things will actually will change the decision because ECMP group, like the members, will change over time. So those things will actually could break the connections. So that's why like it is designed in the blocking way. So hope that makes sense.
The way I read this, it sounds like the gRPC call has to complete within the forwarding decision.
Oh, actually not. So there is no gRPC call in the inline replication. So inline replication is always just attach the metadata inside of a packet. So there is no gRPC call. The gRPC call actually, if we really like, we we'll only do it in the bulk sync, because the bulk sync there are two. Basically, it's a control plan. You have to like sync the flow. You get all the flow out of the flow table, then send to the other side. That's when we may need like gRPC. But inline sync is just attach the metadata or extra header to the packet. System, hey, this is a sync packet. Please create a flow on the other side.
Yeah, and Riff, adding more question to basically this gRPC API, right? Is there a way to, or can we introduce the API to know whether basically the HA connectivity is in a healthy state from the point of view? Is it, for example, in initiating, or is it, for example, doing the flow bulk sync, or the flow bulk sync fully finished? Because from the health of the HA state, right? I understand that once, for example, if let's say cards disconnect with each other, right? And then basically once the some specific DPU comes up, right? It will need to bulk sync the flows, right? And during the bulk sync of the flows will actually not be fully synced. So the second card still cannot, for example, take over or start advertising on BGP, this kind of stuff, right? But the second card can only start, for example, receiving traffic only once the main bulk sync completes, right? So we should have potentially some API that potentially can expose the status of the HA sync stuff, right? Whether it's like in running or establishing and syncing, this kind of stuff, right? So you guys will be also specifying this?
Yep.
The status
so
API?
We actually have those APIs. So we actually even support like multiple modes, because it depends on really the vendor implementation. So we need to support all. But yes, there is actually a component that manage all this HA state machine. It's not in this API, because this API is more like just for sorry, it's not in this HLD, because this HLD is just for like saying that how we are going to implement the data plane application, so it's not really like dive into those like details of the APIs and state machine management. But we do have a full doc and a dedicated doc talking about the HA high level designs, as well as the DPU driven mode, as well as on the side how the API actually looks like. So there are a bunch of like HPLDs over there describing all the behaviors, and you are actually interested.
Okay. Cool.
Yep, sounds good. Cool.
So
Yeah.
just to clarify, Ref, so this what you're referring to here in this doc for the HA side of things, that explains how the standby will catch up to reality after the bulk sync. Because you have to.
Yeah,
Just during the duration of the bulk sync, like Michael was pointing out, you can have more flows arrive, and somewhere the delta has to come.
Mm-hmm. Yep. And so those things are also being handled by the HA design. Yes, but
Okay.
it's not just it is not actually mentioned here because it's just like out of the scope. But for the flow creation, there actually for the flow sync, there actually multiple things could happen. Say the flow is created during the during the sync, and the flow can be also deleted during the sync. Resimulation can also happen in the background. So how we actually handle that? There is actually a flow version gets in play. So we make sure like this, and there is actually out of order if you really think about it, right? Because the inline sync can happen, and also bulk sync can happen. Depends on when the bulk sync actually gets a flow. You may get older version or newer version, and you also may land like sooner or later. So it really depends on the scenario. We need to handle them all, and there is a mechanism based on the flow version to actually resolve all the conflicts and all the things. So those are also described in the HA design. Okay, hope that answers the question. And if not, Junhua, feel free to continue.
Yeah.
Okay. Let's continue. Yeah. For modeling and requirement resource modeling, you can refer to the SONiC dash actual high level design. So I just overlook it. Yeah. Next one is the architecture overview for the data plane APP. We can see the bottom is the dash BM version 2, and the middle block is our data plane APP, and the upper is a controller or side radius. Yeah. Generally, side radius can, here is a dash side client. It can invoke a side interface via gRPC to create side object, for example, EI and routing table and VNet object, etc. Yeah, it's the dash side client sets the request to dash side server. Generally, the dash side server is a slim layer of side interface. It finally invoke the dash side API to create this dash side object in the BM version 2 P4 tables. Yeah, this is left columns, and the right columns is for the packet processing. Yeah, if the BM version 2 receive packets from the DPU ports, yeah, and in the P4 pipeline, it will do flow lookup. If the packet not hit one flow, then the pipeline will trap the packet to the data plane app, and in data plane app it will create a flow here we have a local flow table. That means we will create a flow in this local flow table and offload this flow entry with dash flow API to offload it to the dash P4 flow table. Yeah, here I describe the main objects in this list. Also, the one notable thing is for simplicity, worker thread, maybe the worker thread can directly invoke the dataset API to create a flow in BME version 2 P4 tables. Here introduce a queue. It's just to not block the packet processing in the worker thread. But maybe for concept verification, we can maybe it doesn't matter. Yeah, I just consider the dataset API and it's a blocking API. If we in this work thread directly invoke dataset, it may block the packet processing in worker thread. Okay, any question?
Not from me. Anyone else? Oh, go
Okay.
ahead.
Okay. Yeah, I just reference this figure from HA API HRD. Yeah, it's very detailed for the packet flow. Yeah. So in the detailed design, we have the following subsections. Yeah, the first one is dash metadata. Yeah, because one dash pipeline forward the packet to data plane app. Yeah, this pass the trap to data plane app. It will notify the data plane app to create a flow. So the data plane app will need some necessary information to create a flow. So this information is summarized in the dash metadata header. It includes the flow key entry, common flow data, and overlay the rewrite data, and if you need, and also underlay encapsulate data. Also, if the packet is tunneled, that means we maybe have two underlay layers, and one is tunneled, so we may optionally have a tunnel encapsulate data. So the packet set to data plane VP is like this tag. The enter is we will add a new Ethernet header, and then after it is dash metadata, and so next one is the customer packet. And it's notable the original underlay header has been extracted in P4 pipeline. In before the connection track lookup stage, we have extracted the underlay header. So when the packet is set to the data plane BP, it will only have the customer packet here. And this is the data dash metadata header figure. Yeah, here is listed the key fields. So the one is source, type, subtype, and length. After it is the flow key, flow data, and for flow data, it will the next figure will display the details for the flow data. With this information in data plane app, we can easily create the flow entry. Okay, next subsection is the basic flow. For the design of the basic flow, it's in data plane app, we will have a flow state machine. That means data plane app will run a flow state machine to manage the flow state and do proper operations. It's maybe it just CRUD means creation, replace, update, or deletion. The state transformation can be triggered mainly by two events. One is the package with that metadata from the pivot pipeline. Another one is a timer event for flow age out. If this flow during some time there are no any packet to hit this flow, the flow will be aged out. The below sequence shows the detailed steps of flow creation. Other operation will be similar. Yeah, we can see the sequence chart. Pivot pipeline, pivot runtime, data plane app worker, data plane app master. First one, if the packet is not hit any flow, so the pipeline will set a packet to the data plane app worker. The packet will have metadata and customer package. In the worker thread will then create a flow in local flow table. And next step, it will request the flow offload to this way. Actually, so this step. But I think in implementation, maybe we can simplify this operation. Okay. And the data plane app master will call -side API create flow to create the to set this to call this API with gRPC. Then in pivot runtime will do a real write flow operation to write the flow to pivot flow table. After the writing is finished, the pivot runtime that means this create flow cell returns OK because this create flow API is blocked. Yeah. After that, the master will tell the worker the flow offload is done. Then the data plane app will forward will resimulate will reinject or recirculate the packet read the packet to the data plane, the pivot pipeline. Then pivot pipeline will go through the packet stages. Then this time it will hit the flow and do the faster pass. Yeah. Okay. Any question? Okay. Next one.
Sorry, I was on mute. I
Yeah.
think there's a question on the side in the chat, but I don't know if you want to handle that one after or. I think it's more of a statement / question, Christian. We can keep going.
So what's the question, Christina?
It was more from Christian in the chat window.
Oh, sorry. Maybe okay. Let me check the chat window.
Yeah.
We can also discuss offline.
Sounds good, Christian. Do you want to keep going, Junhua?
Okay. So can I continue?
Mm-hmm.
Okay. Yeah, this is one for flow resimulation, the sequence chart. The upper layer, the dataset client can trigger the full simulation by this ENI attribute for resimulation requested. Then dataset server will receive this request message, and here it will call the set ENI attribute. Here we introduce a internal attribute named ePoach. That means it's someone it's a time of beginning. And okay, in people runtime, it will update the ENI ePoach, and okay, and return okay. Then that server will reply the set client. Means it request returns okay. When packet comes, when packet reach the people pipeline, and when he do flow lookup, it will associate someone ENI. It will find the ENI ePoach would be larger than the flow ePoach. That means this flow entry needs a resimulation operation, so it will not continue the flow fast pass. So it will go through the first pass to do the match and the action stage. So in the seventh step, it will do the slow pass and update the flow data. Then this packet will be trapped to data plane PP worker again. In data plane worker, it will update the flow data. Okay. Yeah, next, for HA flow, it's similar as this basic flow, just it will add an extra flow synced state. That means it involves X-sync request response ping pong between data plane APP and a standby data plane APP. Yeah, for HA flow simulation, it's based on this the basic flow simulation. It will also do the sync EIM ePoach and update the flow data in peer. Okay, for the site design, the below lists the basic operations. Yeah. just like this figure. Yeah, one is accept request. Pass request, identify side object, and construct its attribute list. Yeah, if the side object is implemented in data plane app itself, so it will call data plane app local function. Else, it will invoke dataset API by this side. It's implemented in side library. Okay. After that, it reply the dataset client. It's the raw procedure. Okay, the next section is for test plan. That means it lists the basic test case for this data plane app. It will verify flow CRUD operation in standalone and HA testbed. It will verify the dataset.
Okay.
So
Yep.
for scope, it only covers the functionality verification. The
Not performance. Yeah.
The performance and the capacity is out of scope. Yeah.
Okay.
So for test environment, we only use the BIM version 2 pure pipeline and parse this data plane app. And for packet generation, we can just use skip. Yeah. So this table lists the detailed test case. Yeah. I will not go through them one by one. Yeah, you can check them offline.
Sounds good.
Yeah, basically that's all. Yeah.
So that's quite the PR, Junhua. Thank you.
Yeah,
What are the next steps for us to do for you here? Or if this was just an overview for us?
Yeah. After this HOD is approved by community, and yeah, the following 3 PRs will be the detailed implementation. Yeah, this one is just change in makefile is merged, and this the changes in people pipeline. And this one is the data plane app program. Yeah.
Yeah.
And still make some changes. Yeah.
Yes, I saw that.
Yeah, Riff is
Reviewing.
reviewing it. Yeah.
Yeah. Sorry, that's my dog. Yeah, I saw that this morning, still in progress on those. So thank you, Junhua, for the presentation, and just go around real quick. Did any of y'all have questions on this HLD? Everyone has it memorized. Okay, awesome.
This is Chris.
Hey, Chris.
Hi. Nice presentation and documents. I did
Beautiful.
review earlier too.
Mhm.
Just from let's say the motivation point of view, or let's say the future of this, if this POC is successful, how does this translate into, actual production cases, and what would vendor implementations need to do? Would they need to implement this side interface, or is this something they would implement themselves in their own, embedded processors? Because this is a, BMV2 demonstration of an architectural idea, but how would it translate into, production use case or implementation?
Yep. Hi, Chris. As you can see, yeah, I can understand. Sorry, my audio just dropped.
We can hear you. We can hear you. Yeah.
Great. Yeah, I tried to recover my headset. So as you can see in the whole design, there is no any like extra side APIs or anything like that being added. So
Yeah.
basically, what happens is that this is just for like a reference. It's not really having any restriction how vendor is going to implement the data plan app, or how the vendors actually bridging the gap. So let's say the vendor actually have a really good hardware capability. They actually can do all everything in the hardware. They're
Yeah.
actually free to do everything in the hardware. So this one is just for like us to say, okay, if we for the BMV2 implementation, and this is how the standard people pipeline works to actually how to implement everything that we need in the dash. So this is what is a good option that we could choose.
I see.
But it also doesn't limit how the vendor is going to implement it even in the software side. It's just like, okay, here's the reference. You can check the reference to get some ideas, but if not, you have your own ideas, and it's even
I
better.
see.
That's also good. Yeah.
Okay, that's a good, that explains it. And I guess that one more question is, did you give any thought to modifying BMV2 itself directly rather than having this sidecar kind of thing?
Yep. So I think we also talk about that one like internally. Like even yesterday night we're actually checking chatting about that one. So I think there's still like the certain ways that can extend the maybe P4, maybe BMV2. I think it really depends on what features we need. I think one of the things that we have looked at, because for example like extern, so we can actually create some BMV2 extension. We can put some extern functions in it, which can actually does something like, for example, there is a very like straightforward one is actually the idle timeout, the timer tracking. I'm not talking about like idle timeout, like removing the entry, but it's like, okay, when the next packet comes, right, we actually need to update the timestamp, because the packet actually keep the flow, right? So the timestamp updating is actually preferred to actually happens in the middle of the the P4 pipeline. However, I think standard P4, well, not the P4 and also as well as BMV2, they don't really have this capability. I think even PNA doesn't really have this capability. Other than you use the really the standard the standard one, like the idle timeout dancing. So there's certain features like this can actually be implemented using external function very likely. But there's still some other things that there's still a huge gap over there. For example, when idle timeout, just like we talked about, like we need to remove the other side of the flow, like reverse flow. So and also like for bulk sync, those things is just like, it's really hard to actually do it by just simply extending the the P4. That's why like we check about all these things is like, okay, let's actually come up with this sidecar solution. But it really it's very flexible. It really fills in the gap that no matter how the the underlying the P4 pipeline actually involves, is always can fill in the space, fill in the gaps, because there always will be. And I would say in the foreseeable future. But I'm also looking forward to any like updates in the P4 or any like new architectural solutions, so we can like evolve over time. So
Christina just posted a relevant comment that kind of sort of segues into my next question, but I know we're about out of time. But we're putting a lot of effort into some of these extensions, and maybe some talk about extending what's out there. I mentioned BMV2, but maybe P4D PDK, if we put effort into making that more of what we need it to be, then we get the general purpose improvements in the community too, right? Versus a kind of a specialized application. Just something to think about, long term.
Yeah.
Yeah, that's actually what I was going to ask, Riff, is a long time ago, we used to have a list of things that we were either thinking BMV2 couldn't do, or maybe it was a limitation in P4. And we don't have to talk about it now. It could be maybe tomorrow in the behavioral model meeting, but would this app kind of help handle those gaps?
Yeah,
For
and let me
example,
let me add to it that basically I think from the HA perspective, this may be very generic concept, not only specialized to one specific type of implementation potentially, right? So whatever you guys believe that we should more like generalize in this kind of stuff, right? Let's brainstorm on this one.
yeah, I remember one, it was for the, I'll put it in the chat window, for the write back entries, and we wanted BMV2 to have support for that. Like, would this help with that? But we could talk about it tomorrow. But I'd like to go over that if we can tomorrow. Would that be okay? Riff and
Yeah.
Jimmy and Prince, yeah? Okay, cool. Well, wow, Jimmy, thank you so much. That was awesome. I did have some other ones I wanted to go over, but we only have 1 minute left. Does anyone have an emergency or pressing issue or PR we need to cover before we drop?
Yeah, I think we probably can talk about the ER gateway next
The
week.
next time.
Yeah.
Yeah,
so
I was
that
going to
one is
cover the
not
ones
gonna
that
take too
we,
much time, so.
yeah, and I was going to cover some of the ones we had closed and everything, but we could do that next time. And so I'm going to stop the recording, and I just want to say thank you, Jimmy and Riff, for all of that writing and